Hello everyone, welcome back to our channel Easy Learning. In this video, we are going to see Class 10 Geography Chapter 5 Minerals and Energy Resources. For better understanding, I have divided the chapter into two parts. In this part 1 video, we can see what is a mineral, study of minerals by geographers and geologists, mode of occurrence of minerals, classification of minerals, hazards of mining, and conservation of minerals. We can see all these topics one by one. We use different things in our daily life made from metal. Can you say some of the items used in our house made of metals? You can use comment box. Yes, you are right. Refrigerators, stove, oven, staircases. Okay, very good. Now, let me ask one more question. Where do these metals come from? Yes, minerals. You have studied that the earth crust is made up of different minerals embedded in the rocks. Various metals are extracted from these minerals after proper refinement. Minerals are very important in our life. Almost everything we use, from a tiny pin to a towering building or a big ship, all are made from minerals. Now we can see what is a mineral. Minerals are inorganic, solid substances found in nature. Geologists they define mineral as a homogeneous, naturally occurring substance with a definable internal structure. Minerals are naturally occurring substance. They are not made by humans. Minerals are inorganic. They have never been alive and are not made up from plants or animals. Minerals are solids. They are not liquids like water or gases like the air around you. Minerals have a definite chemical composition. Each one is made of a particular mix of chemical elements. I hope now you understood the term minerals. Next, we can see the role of a geographer and a geologist in the study of minerals. Geographers study minerals as part of the earth crust for a better understanding of landforms. The distribution of mineral resources and associated economic activities are of interest to geographers. A geologist is interested in the formation of minerals, their age, and physical and chemical composition. So we can see mode of occurrence of minerals. Minerals are usually found in ores. The term ore is used to describe an accumulation of any mineral mixed with other elements. Minerals generally occur in these forms. In igneous and metamorphic rocks, minerals may occur in the cracks, crevices, faults, or joints. The smaller occurrences are called veins, and the larger are called lodes. Major metallic minerals like tin, copper, zinc, and lead are obtained from veins and lodes. In sedimentary rocks, a number of minerals occur in beds or layers. Coal, gypsum, potash salt, and sodium salt are obtained from sedimentary rocks. The decomposition of surface rocks and the removal of soluble constituents also form the minerals. Bauxite is formed this way. Minerals also occur as alluvial deposits in the sands of valley floors and the base of hills. These deposits are also called placer deposits. Gold, silver, tin, and platinum are most important among such minerals. Ocean waters contain vast quantities of minerals, but most of these are too widely diffused to be of economic significance. However, common salt, magnesium, and bromine are largely derived from ocean waters. Ocean beds too are rich in manganese nodules. Next, we can see classification of minerals. Minerals are classified into three: metallic minerals, non-metallic minerals, and energy minerals. First, we can see metallic minerals. Metallic mineral is further divided into three: ferrous, non-ferrous, and precious. First, we can see ferrous minerals. Ferrous minerals are metallic minerals that contain iron. They are magnetic. Iron ore, manganese, nickel, cobalt are example for ferrous minerals. Next, we can see non-ferrous minerals. Non-ferrous minerals are also metallic, but they do not contain iron. They are not magnetic. Copper, lead, bauxite, tin are example for non-ferrous minerals. Next, we can see precious minerals. What is precious metal? Yes, a metal which is very rare and valuable and often used in jewelry are called precious metal. Good. Gold, silver, platinum are best example for precious minerals. Next we can see non-metallic minerals. What is non-metallic minerals? Yes, minerals that do not contain any metals. Mica, salt, potash, sulfur, granite, limestone, marble, sandstone are best example for non-metallic minerals. Next we can see energy minerals. What is meant by energy minerals? Yes, if a mineral can provide heat and energy is called energy minerals. Coal, petroleum, natural gas are example for energy minerals. Next, we can see the topic ferrous minerals. We know that minerals which have iron contents in it are known as ferrous minerals. Ferrous minerals account for about 75% of the total value of production of metallic minerals of India. They provide strong base for the development of metallurgical industries. India exports substantial quantities of ferrous minerals after meeting its own internal demands. Two major ferrous minerals in India are iron ore and manganese. First, we can see iron ore. What is an ore? Yes, an accumulation of any mineral mixed with other elements are known as an ore. In other words, see, any mineral mixed with other elements or impurities is termed as an ore. We can see iron ore. Iron ore, it is the most important metallic ore. It is known as the backbone of modern civilization and it is the backbone of industrial development. Many industries depend on iron. So it is also known as the fundamentals of all industries. Iron ore is a naturally occurring solid material from which valuable minerals are extracted for commercial use. Iron ores are rocks and minerals that can be economically extracted to produce metallic iron. They are generally rich in iron oxides. They came in various colors such as dark grey, bright yellow, rusty red, deep purple, like that. India is rich in good quality iron ores. There are four types of iron ores: magnetite, hematite, limonite, and siderite. Let's see one by one. First, we can see magnetite. It is the finest quality with a very high content of iron, that is up to 70%. It has excellent magnetic qualities, especially valuable in electrical industries. Next, we can see hematite. It has content of iron that is between 50 to 60%. It is the most important industrial iron that is used in industries. Next, limonite. It has iron content of about 40 to 60%. Next, siderite. It has iron content of between 40 to 50%. You know that iron ore is very important for the industrial development of the country. So, we can call this iron ore as a metal of universal use. Next, we can see major iron ore belts in India. There are four major iron ore belts, that is Odisha Jharkhand belt, Durg Bastar Chandrapur belt, Bellary, Chitradurga, Chikkamangaluru, Tumakuru belt, Maharashtra, Goa belt. Let's see one by one. First we can see Odisha Jharkhand belt. Actually this region is called Chota Nagpur. High grade hematite iron ore is found in Badampahar mines in the Mayurbhanj and Kendujhar district of Odisha. Hematite iron ore is also mined in Goa and Nomundi in the Singhamam district of Jharkhand. Next, we can see Durgbastar Chandrapur belt. Actually, this belt lies in Chhattisgarh and Maharashtra. Very high grade hematite iron ore is found in the famous Bailadila hills in the Bastar district of Chhattisgarh. Iron ore from these mines is exported to Japan and South Korea. Next, we can see Ballari, Chitradurga, Chikkamangaluru, Tumakuru belt. It lies in Karnataka. Karnataka has large reserves of iron ore. The Kudremukh mines, located in the western Ghats of Karnataka, are a 100% export unit. Kudremukh deposits are known to be one of the largest in the world. The ore is transported as a slurry through a pipeline to a port near Mangaluru. Next, we can see Maharashtra Goa belt. This belt includes the state of Goa and Ratnagiri district of Maharashtra. The ores of this belt are not very high quality, but they are efficiently exploited. Its iron ore is exported through Marmagova port. Next, we can see manganese. Manganese is mainly used in the manufacturing of steel and ferromanganese alloy. Nearly 10 kg of manganese is required to manufacture 1 ton of steel. It is also used in chemical industry for making bleaching powder, insecticides, cells of dry battery and tiles. It is also useful in leather industry, glass industry, matchbox industry, photography, china clay utensils, and colored bricks. It is mixed with iron rails, that is, manganese is mixed with the iron rails to make them more flexible and strong. Manganese steel is very strong steel which is used in machines to break rocks and also in grinding machines. The major manganese producing states in India are Odisha, Karnataka, Madhya Pradesh, Goa, then Andhra Pradesh, Jharkhand, Rajasthan, and Gujarat. Next, we can see non ferrous minerals. We know that minerals which do not have iron contents are called non ferrous minerals. India is deficient in non ferrous minerals. Minerals like copper, bauxite, lead, zinc, and gold play very important role in a number of metallurgical, engineering, and electrical industries. First, we can see copper. Reserves and production of copper is very low in our country. Being malleable, ductile, and a good conductor, copper is mainly used in electrical cables, electronics, and chemical industries. The Balagat mines in Madhya Pradesh produce 29% of India's copper. And the K3 mines in Rajasthan are famous for copper mining. 48% copper is produced in Rajasthan. The Singhbum district of Jharkhand is also a leading producer of copper. Next, we can see bauxite. What is bauxite? Yes, bauxite is an ore from which aluminium is obtained. From bauxite, a clay like substance, alumina, and later aluminium is obtained. Its deposits are formed by the decomposition of a wide variety of rocks rich in aluminium silicates. Odisha is the largest bauxite producing state in India. India's bauxite deposits are mainly found in the Amarkantak Plateau, Michael Hills, and the plateau regions of Bilaspur Katni. Next, we can see non-metallic minerals. We know that minerals which do not have metal content are called non-metallic minerals. Mica and limestone are very good example for non-metallic minerals. Mica is a mineral made up of a series of plates or leaves. It splits easily into thin sheets. These sheets can be so thin that 1,000 can be layered into a mica sheet of a few centimeters high. Mica can be clear, black, green, red, yellow, or brown. Due to its excellent dielectric strength, low power loss factor, insulating properties, and resistance to high voltage, mica is one of the most indispensable minerals used in electric and electronic industries. Mica deposits are found in the northern edge of Chota Nagpur Plateau. In Rajasthan, the major mica producing area is around Ajmer. Nellore mica belt lies in Andhra Pradesh, is also an important producer in the country. Next, we can see rock minerals, that is limestone. It is found in association with rocks composed of calcium carbonates or calcium and magnesium carbonates. It is found in sedimentary rocks of most geological formations. Limestone is the basic raw material for the cement industry and essential for smelting iron ore in the blast furnace. Next, we can see the topic hazards of mining. See, what are the impacts of mining on the health of the miners and the environment? That's what we are going to discuss here. See, the dust and noxious fumes inhaled by miners make them vulnerable to pulmonary diseases. What is pulmonary diseases? Yes, lung diseases. The risk of collapsing mine roofs, inundation, and fires in coal mines are a constant threat to miners. The water sources in the region get contaminated due to mining. Then, dumping of waste and slurry leads to degradation of land, soil, and increase in stream and river pollution. So, stricter safety regulations and implementation of environmental laws are essential to prevent mining from becoming a killer industry. Next, we can see the topic conservation of minerals. Why is conservation of mineral essential? Is it important to conserve minerals? Yes, mineral resources are finite, exhaustible, and non renewable resources. We cannot replenish them after they have been exhausted, as the geological processes of mineral formation are very low. Continued extraction of ores leads to increasing cost as mineral extraction comes from greater depth along with decreased quality. If they finish, our all round progress will come to a halt. Hence, we have to conserve them. Next, we can see some of the methods of conservation of minerals. See, first, we should use minerals in a planned manner. Technologies must be developed so that low grade ores can be used at a low cost. Wastage in mining and processing should be minimized. Where it is possible, plastic materials should be used because rubber can be reproduced. We should use non conventional source of energy more and more, such as solar, wind, like that. Then we should find substitutes. Recycling of metals should be encouraged. A concerted effort has to be made in order to use our mineral resources in a planned and sustainable manner. Dear viewers, I hope you have understood the concept Minerals and Energy Resources Part 1. If you have any doubt or comments, you can comment in the comment box. Thank you for watching. We'll meet you back in next video. Until then, bye.